So in the previous video, I was talking about finding the angle beta. Actually, here there's a mistake. It is sine beta over the side opposing it, which is actually f1 here. It happens here that both f1 and f2 have the same magnitude. That's why the answer will be the same. So actually here sine alpha over fr equals sine beta over f1, sine 60 degree over 3 equals sine beta over 3, 3 and 3 cancels. So sine 60 equals sine beta, mentally then beta is 60 degree, or you can use inverse sine. Now for figure 3. Figure 3 includes the three forces acting on the same particle. F1, F2 and F3, in which the angle between F1 and F2 is 90 degree and they are perpendicular. One is already along y-axis, and the other is already along x-axis. However, the third one, F3, is oblique. With respect to this frame of reference means it has an x component and a y component. Now I'm going to use projection method in order to solve this problem. By projection method, I mean that I want to find the x component of each force and the y component of each force, and then add all the x components together and all the y components together. As for F1, it's clear that it is vertical along y-axis, so it doesn't have an x component or horizontal component. It's only considered to be having y component, and F2 is horizontal, so it has only x component but doesn't have y component. However, F3 have both y and x components. So starting with x-axis, I'm projection along x-axis. Let us find the sum of forces along x-axis. What are they? It's f2 vector plus the x component of f3. How do I represent the x component of f3? By taking the top of the vector and drawing a perpendicular to the x-axis. The point at which it reaches x-axis, we join it to the origin of the frame of reference. So this represents f3x, or the x component of f3 vector. Now f2 vector plus f3x vector are written in this way. If we want to get rid of the vector representation and now deal only with magnitude, so the magnitude of all the forces on x-axis, now I have to take into consideration the positive direction and the negative direction. F2 is in the positive direction of x-axis. That's why I write plus F2 as magnitude. However, the x component of F3 is in the negative direction. That's why I have to write minus F3x. Now I get 2 Newton minus F3x. How can I find the x component of F3? Making use of geometric properties. In this triangle, we have that cosine 45. Here I have to mention something. That we are given. Oh, sorry, something is wrong here.